So we are starting a unit in geometry, and today we're going to be focusing on squares, rectangles, and parallelograms, and simply finding the areas of those. I think you probably have done this before, so most of this should be review. So we're just going to go over the do now and do some problems involving area, and tomorrow we're going to do triangles. So for today, we're going to focus on squares, rectangles, and parallelograms. So go ahead and turn to the next page, please. So for this do now, you're comparing some different designs, and you can see that as far as area is concerned, that each of these designs has 6 boxes. So the amount of space that's covered by each shaded box is the same for each design. They each have 6 shaded boxes that are the same size. So the area is the same. The perimeter, though, is a different story. That's the length around. So if you look at the perimeter for design A, I'm going to count each box as 1. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for design A. But if you look at design B, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you can see that having the same area between two different shapes does not necessarily mean you have the same perimeter. And like I said, we're going to be just focusing on area for the most part today. So go ahead and turn to the next page and we'll get started talking about how you find area. All right, let's talk about how we find the area of rectangles and squares. So the area measures the space inside a figure. So let's write the word inside there. And when we measure, we use square units. So if the length is measured in feet, it's feet squared, or it's inches squared. Whatever the length is given to you, whatever those units are, it's going to be the units squared is always going to be part of your answer. So how do we find the area of a rectangle? Well, we use this formula, and I think you've seen this before. We say that the area is the length times the width. And on a rectangle, we might label it like this. There's an L for length and a W for width. And it really doesn't matter which side you label the width and the length. I could have switched those up, and it doesn't really matter which one you decide is the width or the length. And you'll see that as we do some example problems. And then if we're dealing with a square, that's a special situation. That's actually easier. The area of a square is just the length of the side squared. Or I guess you could say side times side. So I'm going to say S for one side of a square, but because it's a square, we know all 4 sides have the same length. So S times S is going to be S squared. All right, so we've hit a couple of important words in what we've talked about so far, and I just want to put those down just so we keep thinking about them. Of course, area is the most important word. And then length is important, and then width is important. And we'll see if some more important words come up a little bit later. Okay, so here's a couple of practice problems. I'm going to do these with you. So here's a square. We want the area. So we have a side length of 3. So my area is going to be 3 times 3. And that's going to be 9. And we don't have any units for this, so we just say units squared when we're not given anything. Just like that, okay? For this problem down here, we have a length of 5 and a length of 11, so we're going to have 5 times 11 equals 55. Units squared. Okay, that's all there is to it. So go ahead to the next page and we'll do a little bit of practice with this. So for this first problem, we have several rectangles that are on a grid, and you're going to find the length and the width, and then find the area. I'm going to do rectangle A for you. So again, the length and the width can be either one. I'm going to call for this one, for A, the length. So I'm going to count the squares to figure out what that is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to say this length for A is 10. And I'm going to say the width is 1, 2, 3. And the width is 3. And of course the area is going to be 10 times 3. And the answer is 30, of course. And again, that's going to be square units. We won't need to write that for this table. So go ahead and complete this table, and then I want you to answer number 2 as well, and then come back and check your answers. So pause the video and work on these problems. All right, go ahead and check out these answers. See if you got the same numbers in the table here. And then question 2 is about, do I actually need to see the rectangle to find the area? And the answer to that is no, so the answer to this question is yes. Can you determine the area of a rectangle without drawing it? And the answer is yes, because I only need to know what the length and the width are. I don't really need to see the rectangle to figure it out. So in this example, if I just tell you that a rectangle has a length of 5 and a width of 7, I can tell you what the area is without actually seeing that rectangle in front of me. All right, let's move on to the next page and look at some different types of problems. So we need to review 2 concepts. We need to talk about parallel lines and perpendicular lines. So let's talk about those definitions and then draw some examples of what they look like. So first of all, parallel lines are parallel if they are in the same plane and they never cross, or they never touch. And perpendicular lines are lines that they do cross, but they cross in a very special way. They cross at a 90-degree angle. And we'll take a look at what that means. So let's use this dot paper to draw parallel lines. And I'm going to do this as carefully as I can. I'm going to follow these dots. And then a few below that, doesn't matter how few below, I'm going to do the same thing. Again, follow those dots as best I can. So I hope you can see that those 2 lines will never cross. They're never going to meet up. They're never going to touch. And that's what it means to be parallel. Now perpendicular, on the other hand, I'm going to draw one line that follows the dots down here, again, as best I can. And then I'm going to draw another line such that it meets this one at a 90-degree angle. Again, following the dots. And those are perpendicular. And we know that the angle here is 90 degrees. So it makes a perfect corner. This would be one way to think about it. So the reason we're talking about that is we're going to talk about another shape called a parallelogram, which is a lot like a rectangle, but it's kind of a slanted rectangle. So we're going to draw one here, and we're going to start by drawing two parallel lines. Something like this. I'm going to make it I'm going to cross 5 dots. And I'm going to draw another parallel line, but I'm going to start it farther over, but I'm going to make it the same length. So it's parallel lines, but they're the same length. And then I'm going to use a diagonal to connect both those sides, the two endpoints, to close this picture. So it's going to look something like this. Okay. We'll pretend those are straight. I know they're a little wavy, but pretend they're straight. This is a parallelogram. And all it means is that the sides are parallel. Opposite sides are parallel. This is parallel to that, and this side is parallel to that side. So it kind of looks like a rectangle, but again, it's kind of slanted. So we're going to figure out how to find the area of one of these slanted rectangles or these parallelograms. So go ahead and turn to the next page. So if you take a look at this drawing in number 1, Josiah starts off with this parallelogram, but then he takes a piece, separates a piece from it, and just changes the location of that piece over to the other side. So it's kind of hard to find the area of a parallelogram when it looks like this, because it doesn't work the same way as a rectangle. But by doing this, he turned it into a rectangle, and we can figure out what that area of that rectangle is. So let's see, how many blocks do we have here? 1, 2, 3, 4, 5. So we have 6 blocks for the length, let's say. And then the width is 1, 2, 3, 4. So that area is 24 units squared. And then part B asks, is the area of the final rectangle the same as the area of the original parallelogram? And it absolutely is, because we're still taking up the same space. We just moved a section over to here, but the total space that's taken up inside hasn't changed. So the area that I found for the rectangle is the same as the area for this parallelogram. All right. So, of course, the answer to this is yes. And I'm just going to say the space inside is the same. So that leads us to a slightly different formula for the parallelogram. So you can see that we used this length and this width to get the area of the rectangle, which also gave us the area of this parallelogram. So note that the area of the rectangle is length times width, and the formula for the area of a parallelogram is base times height. So I want you to think about how these two formulas are different and how they're the same. So go ahead and pause the video and answer the 2 questions down here. Just take a couple minutes to do that. and then come back and see if we came up with the same answers. Alright, so some things that are the same about the two formulas are we're still multiplying, two numbers to get the area. And with a rectangle, the width and the length are perpendicular. Those are the two numbers we're multiplying. For a parallelogram, both the height and the base that we multiply are perpendicular. So the things that are different, so for a parallelogram, the one number is not the actual length that we use. We actually use the height. So we're not using the length of a side like we do with a parallelogram. And of course, just the words are different. Width times length and height times base. And they're different on purpose because they represent different things. All right, so go ahead and turn to the next page and we'll do some practice with this. All right, so you're going to use these grids to find the area of some parallelograms. I'm going to do the first one for you so you get the idea. So we need a base. So I'm going to call this the base. And we need a height. And again, we can't use the diagonal height here. We need a distance from the top straight down to the bottom. So our base is 3, and our height, that perpendicular distance, right, because we need, let me do this in a different color. If we extend our base, then we need our height that's perpendicular to that, and that's going to be 1, 2, 3, 4, 5 blocks. So the area for this one is going to be 3 times 5, which is 15. Okay? All right, so I want you to do the 3 other rectangles in the grid, and then figure out this area, and then come back and check your answers. So go ahead and pause the video. All right, check out these answers. Again, the key thing is that the two sides that you're using have to be perpendicular to each other. That's the key. So check your answers, see if you got something different, and see if you can figure out why if you did. And after you do that, go ahead and turn to the next page. All right, for this problem, I want you to think about an explanation for this. So Mark cut off a slice of the original parallelogram and then placed it over here in a weird place. And he's claiming that the area of this is the same as the area of this. So I want you to decide if you agree with Mark and then explain why or why not. So go ahead and pause the video and answer that question, and then come back and we'll compare answers. So if you take a look at this, I disagree, because this section in here, this overlap, is only counted once. It should be separate from this piece so that it gets counted individually by itself, as well as the area that gets counted in here. So if you overlap it, you're not counting all of the area correctly. So they do not have the same area. All right, real quickly, for number 4, just basic finding the area of these parallelograms. Let's do these together real quick. So we have a base of 3, and then a height, looks like a height of 5. So the area is 15. Oh, we can do that over here. And again, we don't really have units. And then D, we have a base of 3. I always start with the one that's easiest to see. And then we have a height of 5 again. So this is also going to be 15 units squared. And I think the point of this piece is just that, you have these two parallelograms that are situated differently, but and you can see how the base and the height are situated differently, but you still end up with the same area. So go ahead and turn to the next page, please. All right, for these problems, we're going to bring that concept of perimeter back into the situation. And let me just get you started a little bit with this example. So we know that the perimeter is the entire length around, and they give us one of the sides. And the question is, can you find the lengths of the other sides when you know what the total perimeter is? And they do it a certain way here, which I think is interesting. They take half of the perimeter, so they know that this length and this length will add up to half the perimeter. So they know that this other side has to be 3. The way I think about it, actually, is that if this side is 5, this side is 5, that gives me a total of 10. If my total perimeter is 16, that means that this side and this side have to combine to be 6. So that tells me that they each have to be 3. And now I can use that information to find the area. So basically they're giving you perimeter information and asking you to figure out what the side lengths are and then what the area of the rectangle is. So go ahead and pause the video and work on those, and then come back and check your answers. All right, check out your answers. If you got the same answers, that's excellent. If not, see if you can figure out where you went wrong. And once you finish this, let me know if you have any questions, and I can give you the homework when you're done with everything. All right.